All right, let's dive right into this explainer. We've got a massive, honestly mind-expanding journey ahead of us today. We're going to start by tackling some of the absolute deepest philosophical questions about reality, like the literal nature of existence. And we're going to trace those ideas all the way down until we are looking at a nanometer scale physical microchip. It is incredibly rare that we get to see pure abstract philosophy translate directly into hard, manufacturable engineering, but that's exactly what we have here. So how do we actually do it? Let's take a look. Here is our roadmap for the breakdown. First, the geometry of persistence. Then, rethinking time and observers. The brain's hidden math, what the data doesn't say, and finally, actually building the weave chip. So section 1, the geometry of persistence, the fundamental foundations of SFH-SGP. Now, think about this concept for a second. In this framework, mathematics is not invented. It is the structure of persistence itself. Basically, we're saying math isn't just some human-made symbolic language we use to describe the world. No, it's the literal reason why stable things survive and unstable things just vanish. Complex, lawful systems emerge simply because recursive structures accumulate. Mathematics is the actual architecture of survival. And this leads us to a profoundly different way to define existence itself. Instead of just vaguely assuming that everything exists, this framework gives us a stability selection ontology. It's kind of like natural selection and evolution, but for the fundamental building blocks of reality. Existence is earned through survivability. If a mathematical organization is stable enough, it sticks around long enough for us to experience it. This perfectly explains things we observe in the universe, like lawful regularity, particle persistence, and decoherence. It's not magic, right? It's just the geometry of persistence. Moving right along to section 2, rethinking time and observers, redefining the fundamental. Okay, this next part completely flips the script on the building blocks of reality we normally take for granted. In traditional physics frameworks, especially in quantum mechanics, the observer is often treated as something fundamental, almost magical. But the SFS-GP view, it completely strips away that mystical status. It redefines the observer purely as a localized, stable, recursive organization. Universal interaction is happening everywhere, all the time, but the localized observer is really just a specific, stable, geometric shape of information. And naturally, if we redefine the observer, well, we have to rethink time too. In this view, time is emergent. It is absolutely not some background container that the universe just sits inside of. Instead, time is the sequential, stable reconfiguration of these organizational transitions. Imagine it like basin hopping or metastable dynamics. Time is literally just the geometry of how one stable organization transitions and locks into its next state. All right, section 3, the brain's hidden math and the empirical falsification program. 0. Now that is a massive number in this context. Researchers took this philosophical framework and actually put it to the test using CHB, MIT, EEG brain data. They ran an empirical falsification program, testing over 30 reduced-order intervention models just to see if they could simplify the brain's organizational structure. They used a super strict 15% survival criterion. And out of all those models, testing single features, pairs, even quadruple preservations, exactly 0 survived. 0. You literally cannot reduce or simplify the system. It proves true organizational irreducibility. So if we can't reduce it, what actually keeps this structure persisting? The data nailed down 5 required organizational factors: zero lag synchrony, propagation ordering, phase locking structure, coalition persistence, and burst coincidence structure. The crazy thing is, the entire organization completely collapsed unless all 5 of these interacting alignment mechanisms were preserved at the exact same time. It entirely ruled out simple variables like kurtosis or heavy tails. And when you look at the state space analysis, the results are staggering. A massive 97.5% of the variance in the Kuromoto organization was explained by just the first principal component. That leaves only 2.5% for everything else. To put that in plain English, this extreme dimensional compression means we are absolutely not looking at random, unconstrained chaos. We are looking at a system strictly governed by tightly constrained local geometry. Which brings us to section 4, what the data doesn't say, bounding the claims. Look, as incredibly exciting as these findings are, we've got to be scientifically rigorous and talk about what this data does not claim. The allowed directions, the stuff the data actually backs up, are concepts like attractor topology, constraint manifolds, and metastable dynamics. But what is strictly disallowed? Any claims about consciousness, qualia, subjective experience, or biological exclusivity. The flashlight is pointed strictly at mathematical organizational dynamics right now. We are entirely avoiding unproven metaphysical leaps, which is exactly what keeps this science robust and falsifiable. Finally, Section 5, Building the Weave Chip, Grounding Theory in Silicone.
Okay, here is the ultimate payoff. This is no longer just a theoretical proposal. What we're looking at is the actual repository structure. This is the tangible, literal blueprint hosting the code and layouts needed to build this architecture. We've got binary GDSI layouts for a 1.2 square millimeter die, Verilogé models for stochastic spin dynamics, and TCL scripts defining the atomic layer deposition steps. It's the whole shebang, a complete design package enabling chip designers to actually simulate and fabricate this exact mathematical geometry.
Let's geek out on the specs for a second. We are talking about state-of-the-art TSMC NUN 7 nodes, featuring a 32 by 32 core array of tiles. But the real magic is in the memristor arrays, 10 by 10 per core, perfectly integrated into the back end of line. Why memristors, you ask? Because these unique components physically remember their electrical state, which makes them perfect for emulating those low-dimensional attractors we just saw in the brain data. This chip literally embodies the geometry of persistence in physical silicon, and it supports massive scalability using 2.5D stocking via CoWoS. And since this is real hard engineering, the pipeline is super clear. EDA engineers get a direct, highly scalable 4-step workflow. You import into Cadence Virtuoso, synthesize with Synopsys Design Compiler, verify the layouts with your Calibre rules, and finally, fabricate using the TSMC N7 PDK. It takes those abstract constraints discovered in brain data and turns them directly into a manufacturable silicon reality. It's just wild. So, we've journeyed all the way from the deepest ontology of survival straight down to a TSMC fabrication plant. We've actually built the geometry of persistence into silicon. But, by keeping our scientific claims strictly bounded earlier, we're left staring at maybe the deepest unresolved issue of our time. It's a profound question that demands we keep exploring. Think about it. Even if we perfectly map the math and we perfectly build the chip, why does stable organization correspond to experience at all? That is the next great frontier. Thanks for joining me for this explainer, and remember, keep questioning everything.